So thanks for attending our 3D Solution Spotlight on CAMWorks. We're going to start this week by going over this drone part that we've created previously in some SOLIDWORKS demonstrations. So what they did was they went through the parts and the whole assembly and took different pieces of the assembly and either tested them or created them from scratch. And kind of showed the whole process and how to design this part. So what we're going to do in the next three 3D Solution Spotlight, so every Friday in January, we're going to go through one part of the manufacturing process. So this week we're going to start with the frame and the mounting plates. So they're all the same material, they're all the same thickness. So we're going to go through some nesting. We're going to nest these pieces. We're going to make a few extra copies of them. So we'll show that whole process and then how to actually machine them inside of an assembly machining. And then week 2 we are going to go over the outer shell mold. So these blue pieces here, these were actually, or if we were to create these, we're going to put them into a mold or create them into a mold. So we've created the mold pieces and we're going to show you how to machine those molds. And then the week 3 we're going to go over the propeller parts. So there's little knobs on the ends of these propellers and we're going to show basically how we would cut those if we were to cut those in a mill turn machine. So this is the frame we're covering this week. Again, it's all the same material, the same thickness. And we're going to go over NestingWorks as well as assembly machining. So NestingWorks, if you haven't heard of it yet, it is another add-in for SOLIDWORKS. So it's all within the SOLIDWORKS interface. You don't have to have CAMWorks to have NestingWorks. It is very easy to learn and use, and I'll show you the interface today, obviously, when we go through this example, and you'll see how easy this is to use. Part-in-part nesting, it's fully automatic and true shape nesting solution. And it also has both fast nesting and optimal nesting with time constraint options. So if you are looking for a more optimal nest, then we can actually limit the time that we want to nest those. Full associativity with SOLIDWORKS, so if you do go back and change part of the model that you're actually nesting, it will actually update into the nested assembly that we create. It automatically nests, so you don't really have to do much. You just give it a few options that you would like, some distances that you need the parts to be spaced, and then it will automatically nest for you. And it uses material optimization, so if you have multiple different materials listed in your SOLIDWORKS assembly or on those parts that you want to nest, it will actually separate those materials. So it'll use a sheet for, say, plastic and a sheet for wood, whatever you want to nest. The same with thicknesses. And improve utilization and increase in productivity. So I'm just going to exit out of this. And we'll open up the software. So I'm doing this in SOLIDWORKS 2017. And the first thing actually that I'm going to do is create a new assembly file. So I'm going to go and create that new assembly file in SOLIDWORKS. And I'm just going to bring in the parts that I actually want to nest. The first thing I want to do actually is change the unit. So I'm actually going to do this in metric. Again, it can be done in both metric and imperial, so either way. Today we're just going to use metric. And then I'm going to go ahead and add in my parts. So I'm going to say insert components, and I'm going to find the parts that I actually want inside. So this is my drone folder, so they've got them all of the parts listed in here. So I'm going to look for my camera plate, and I can use the control key and select each piece that I want just by clicking on them, and then they'll bring them in at the same time. So it saves me some time by doing that. And then I can choose open here. So I've got 4 different parts, and all I'm going to do is place these into the assembly. It does not matter where they are. I'm using the same configuration for each one of these. So this is basically just an assembly to tell the nesting software what I want to nest. I'm going to choose to save this, and I've got a parts folder that I've created, so I'm going to call this frame, and then I'll choose save. So we need to save it before we can nest it. And then I'm going to come into my NestingWorks tab. So this is an add-in, so if I come into my add-ins, you'll notice that I've added in NestingWorks 2017. So I've added that in, and now I'm going to create the nest job. So this is the button on the left-hand side here. There is the option of nesting by folders, so if I did just want to put these parts into a separate folder, I could actually just choose nest by folder, and it would select just those parts for me. We also have some unfolding options for sheet metal parts. So I'm going to choose Create Nest Job. And this is going to bring up the actual nesting interface. So we've got this Create Nesting Job window that pops up. And the first option here is the actual assembly. So if I do want to go ahead and change the quantity of every part within the assembly, I can easily just do that by highlighting the assembly and choosing a different quantity. So maybe I'll make 50 of these parts. You'll also notice as I kind of step through each one of these parts, it gives me a little preview of what that part is, and it also shows me in highlights on the screen which part I'm working with. So you can see all the different parts as well as the normals with that little arrow. So most of these I do want to rotate on a 90-degree angle because they are fairly rectangular. The main frame I might want to turn on maybe a 45-degree angle, so I can choose this part angle list. And what that does is it's going to flip things either 45 degrees or a 90-degree increment. You can also change this to a different number, say for example 1 degree increment. Oops, sorry. So if I do want to flip this on a 1 degree increment, it's going to take quite a bit longer to nest because it's going to fit that part within 1 degree increments. So I like to kind of leave this at 90 degrees, especially if it's a rectangular part, or a 45 and 90 if it's not. And again, depending on how much material you want to save and how long you want to wait for the part. You will also notice that there is a material selection here. So again, these are all the same material, but if it wasn't the same material, it would actually be listed in the materials list. And they are taking the material settings from the SOLIDWORKS part file. So whatever you set that material in SOLIDWORKS, it will actually list that material in the nesting. The thickness is also located in here, so again it will nest different thicknesses on different size sheets. So you can set that up as well, and you can also override any of these in this window if you'd like. So you just click on that actual material or part and change the material or the thickness or quantity. So the next tab in this nesting job window is the sheet data. So if you look inside the sheet data window, we've got quite a few different settings based on the sheet itself that we want to use. So the thickness automatically is chosen from the part data, so that was the thickness of our parts. We also have a quantity of how many sheets we actually want. So I usually like to leave this at a fairly high number because I'd like to find out how many sheets I actually need to create the nest. However, if you only have maybe 2 sheets in stock in your shop, you could set this to 2 and it won't actually go over the amount of sheets that you have left. It'll actually nest whatever it can on those 2 sheets, and then it'll let you know which ones it couldn't nest. So it's a really good program for either letting you know how many sheets you need or limiting to the amount of sheets that you actually have. Material, again, it's going to add the thickness with the material. If there is another sheet that needs to be added for a different material, it will add that below. The grain direction, both on the part data and sheet data, so you can set up the grain to match. Assembly template, so we can choose different templates. I've got standard size sheets as well, so if I choose the arrow or the drop down here, you'll see all the different standard sheet sizes that they have in the library. These can also be adjusted. And then I can also add in custom size sheets. So maybe I want 1,000 millimeters by 1,000 millimeters. So I can just add in whatever I want. And you can also save out a sheet DXF. So if you do end up nesting this file and you have some material left over on that on a sheet, you can actually save out the DXF and then use that on the next program, and it will only nest with the leftover material from this specific program. So once I have my sheet selected, I'm going to choose Add Sheet. If I choose this again, it's going to say a duplicate sheet can't be added, but the quantity can be modified. So if I did have multiple different materials, I would just keep adding the sheets until all the materials are filled out, and same with the thicknesses. So it shows me a quick preview of what that sheet's going to look like. I can also remove that sheet, change the settings, and then add a new one if I wanted to. We do have multi-head options. I'm actually going to be cutting this on a laser machine, so I don't need the multi-head options in this program. And then the Options tab goes over your part-to-part distance as well as your part-to-sheet distance. So you can tell it how far you want it to cut or place these parts to the edge of the sheet and between each part. The output assembly, it shows exactly where that's going to be saved, so it actually saves in the same file location as my first assembly, so this assembly was saved. I also have the location of the assembly templates. I can also save the output of this nested file as a DXF, so quite a few routers out there or different machines will actually only take DXF to run their CNC programs, so this is definitely an option if you just want a DXF file, but if we do want to take this into CAMWorks, then we're not going to need to use that. So here are the nesting types. There is fast nesting and the optimal nesting setting. So like I said earlier, if you do want to set this to optimal nesting, there are different time constraints below, and I can set up different settings here for more optimal nesting. So if you do maybe want to start this when you leave for lunch, set it to no constraint, and then come back for lunch, it'll be finished. So if you do want a little more optimal nesting, you can set that up. But I find fast nesting works really well, and I'll show you kind of the result that I get with fast nesting. And then I can also create a separate assembly for each sheet that I create. So if I check this create separate assembly box off and create the nest file, it will actually create multiple assemblies for each sheet. Whereas if I don't choose this, it's actually going to create a new configuration for each sheet. And I'll show you that once we nest this. So once we've got all of these tabs filled out the way we want it, we can choose the little preview nest option. So if I choose preview nest, it's going to give me a small preview of what this actual nest job would look like. So layout 1, this is my first sheet, so it shows layout 1 of 4, the thickness, the utilization of the sheet, and how many sheets I would actually need of this. So in certain cases you might have 3 of this sheet and then 2 of the next or something like that. So it'll show you how many sheets, and then it also shows each part and how many of those parts are actually on the sheet as well. Lots of different settings in here, and then we also can go to the second sheet and see exactly what that's going to look like. So there's 4 different sheets that I've got in this list. They all look pretty good, so I'm going to go ahead and say generate nested assembly. And if it didn't look good, you can always press cancel, go back, make some changes, and then preview it again. So that's a new feature actually in the 2017 version of NestingWorks. And the preview is a great option because if you do have to nest it and then go back and change it, you would have had to close it and then re-nest it. So the preview option is really great. So what this is doing right now is it's going through each sheet and it's nesting all of the parts on each sheet and creating those configurations of the layouts. So you'll also notice there is a sketch that's created on each of those sheets, and that's the actual stock material, so the sheet or the the sheet that we actually told it to create for us. It's going to create a sketch of that, which we can actually use as our stock for our CAMWorks file. So it does come up with this little window that says, do you want to proceed to add nested parts to the CAMWorks part manager automatically? So yes, I do. This is a great option because it actually goes through and adds everything into your part manager for CAMWorks assembly file. So if you have machined in an assembly mode before in CAMWorks, you would have to go into the part manager and select these parts, and this will actually select them for you. So it's a really great option and starts your CAMWorks programming quite a bit faster. So you can see it is starting to nest. Those parts are actually getting onto the sheet, and what it's doing now is it's creating the results summary. So it should open once it's finished nesting here. And this is the first sheet that it's created, so it always starts with that one. And now it's ready to show us the results. So I'm going to press OK, and it's going to open this results summary for me. So in this summary, it lets me know how many parts. So I wanted 50 parts nested, and 50 parts were nested for this part and all 4 parts that I asked it to nest. If it couldn't, say for example you only had 2 sheets and you let it nest what it could, it would actually say I tried to nest 50 but I only got 25 of those. So it'll actually let you know how many more you have to nest. So then we have total number of parts nested, so there were 4 parts altogether. We have total number of part instances nested, so all of these. And then we also have the utilization of each sheet. So you'll notice that the first sheet has 83 parts, and it utilized 39% of that sheet. So these 4 sheets, and the overall utilization is 29.3. So again, if you did maybe use optimal nesting and set it for a time, it might use it or get a better utilization percentage. If I close that, I can open that results summary at any time, so it's just a little button in the nesting window here. And now if I look at my SOLIDWORKS design tree, so these are all the different parts that I've got, and then these are the ones that are on different sheets, so you can kind of see the different configuration settings here. So then if I go into my configuration manager, you'll see layout 1, this is the material that was used, this is how thick that sheet was, and how many of those sheets we need to cut. So again, if it did use 2 of these sheets, it would actually say quantity 2, and you would know you need to create 2 programs or cut 2 programs. So if I go to the next layout, so layout 2, it opens up the second layout here, layout 3, and so on. So I can go through each different layout and see exactly how they're set up. And at any time you can obviously move these parts around, so it is just an assembly. So if you do want to adjust some things, then that's not a problem. If I go into my CAMWorks feature tree, I'm now actually ready to machine this. So I've got the first sheet set up here. And you'll see the part manager is full of all of the different parts that I've actually asked it to nest or add to my part manager. So my camera plate, the main frame, the cover, and the power distance board. So if I actually go into my manage parts, you'll see I've got all of those parts inside this window, and I can actually add, or sorry, sort the instances. So all of the instances have been added, and then I'm going to sort the instances. So it's already set up as a grid pattern, so it's going to start in the top left corner and do a horizontal zigzag of these parts. So I'll press OK and just update those instances. I can also add in subprogramming within an assembly file, so that's just the checkbox in this Manage Parts window. So those are all the parts, again, in my part manager that I want to machine. I'm just going to minimize that so it doesn't get too confusing here. And I'll come into my CAMWorks 2017 workflow. So again, I'm going to make sure that this is on metric, so it followed the same units that I asked it to follow within the NestingWorks program. and then I can change my machine. So I'm going to go in and define my machine. And again, I said I'm going to use the laser machine, so I'm going to select that machine. My tool crib, you'll notice that I have a laser tool crib created, and I've set that to be used when I'm using the laser machine, so I've linked them together. So I'm going to use that laser machine, and again, there's only one tool because it is the laser, and I just set it to the actual size of the diameter of the laser beam. So that's the tool that I'm going to use, and then I'll set up my post-processor. So my machine is set up, and now you can see that it's set to laser. And then I can use extract machinable features to find all of these parts. I need to set up my stock, so I first define the machine, now I need to set up my stock, so that's the next thing in the workflow tab. And you'll notice that the stock has actually been set up already. So it actually took the thickness of the part and it fed that information into the stock manager, and it also selected the sketch that was chosen to use for this sheet. So the nice thing with the stock inside of the CAMWorks software when it's linked to the NestingWorks is it's all set up for you, which is great. So we've got the stock, and now we can use the extract machinable features. So with extract machinable features under our CAMWorks options in the mill features tab, you will see that we can tell it what we want it to find. So for the laser machine, I've actually set this up a little different than I would for a milling machine. So for holes, if it does find holes, I want the hole recognition options to be changed. I want the max diameter to be 0 millimeters because I want every hole to be treated as a pocket. So the laser is actually just going to do a contour toolpath no matter what size of hole it is. So I don't want to do any drilling. The non-holes, again, those are pockets, slots, a bunch of different features that basically aren't listed on here. And then you've got the boss features, which are any kind of outer profile features, as well as part perimeter features. So that's just going to go around the outside of each of those parts. So I do want part perimeter checked off. I want to treat that as a boss type, which is, again, the contour toolpath. And then I'm going to set this to the manufacturing view method. So once I've got that set up, then I'm ready to use my extract machinable features. So if I choose this, again, there are quite a few parts on this assembly. So it will take a little bit longer than normal, but the nice thing is it's technically only looking at one instance of each part, and then it's just making a copy for each other part on the screen. So it's really just kind of extracting the machinable features from 4 parts. So it's going to go through and find all of those parts and then make copies and list them in our feature tree here. So we should see all of those parts being listed here. And this is going to be, again, a fairly large program, so this list should be fairly large. Once those parts or those features have been found, we can again go through and change all of the different machining strategies for those features. I've actually set up a laser strategy for each one of these features, and I've asked those to be used by default when I use the extract machinable features for this laser machine. So under my setup 1, again, these are all coming in from the top here. We've got our perimeter feature for all the small parts, the irregular boss. We can kind of scroll down through all of these different features and find each one and double check whether they're there or not. But instead of doing that, I can actually generate all of these and double check with my simulation whether everything's been cut or not. There are a couple that I will definitely want to take a look at. So say, for example, these 2 irregular slot features. Those features are actually going to be cut with the perimeter cut, so I do want to delete these before I generate this operation plan. And again, so that might be a reason why you might want to go through some of these features and just double check that it's not cutting something that's already been cut. So the next thing that, again, I want to do is generate the operation plan. So what that's going to do is take that feature and apply the machining strategy to it. So all of my laser strategies are actually just a contour toolpath using the laser tool. So I've set them all up to be the exact same, which is fairly easy for a laser machine. So we can see back on this list that everything's been generated. They're all turned black. And then if I come back into my operations tree, you can see that I've got now all of my contour mill toolpaths. So once I've got the toolpaths here, I want to actually see the toolpath in the program. So I can choose Generate Toolpath. And then if I click on the actual contour toolpath, we should be able to see a tiny blue line go around the outside of these features. So again, you can kind of see in this Contour Mill 1 toolpath, it is actually cutting all of these features. So with CAMWorks in an assembly machining setting, we can actually choose to machine different parts at a time. It doesn't have to be all set together like this. So what this Contour Mill 1 is going to do is it's going to do the outside of each one of these parts and then go on to the next toolpath. So again, we can change that so that it basically does this part and then this one and then this one, depending on how we want to set that up. We can also sort these toolpaths the way we want them, move them around so they can be dragged in any different setting or location. If I right-click on the setup, we can go into sort operations. This actually won't really take into effect in this case because they're all the exact same operation type and they're all the exact same tool. So I can't really use the sorting option in this case, but again, in, say, for example, a milling or a router program, we would be able to use that. So now that I've got all of my tool paths here, I can use my simulation settings. So we've got a couple different simulations that we can use. So we do have the step through tool path option, and step through will actually let us step through one by one. I'm just going to hide the holder so that we can kind of see where we're going with this tool. The tool is very small, obviously, but we can kind of step through and see all of the different tool paths and where they're cutting. So this is a great window, especially if you do want to do any kind of troubleshooting and kind of figure out where you're at in certain situations. So if you did have a problem with, for example, this tool path on this part, we could figure out what type of move it was making at that point. Again, find the coordinate of where that is, the length, the spindle speed, feed rate, the tool path and the tool that it's using, and time settings as well. So that's the step through toolpath option, which is a great troubleshooting technique. And then we also have the simulate toolpath. So simulate toolpath simulates against the stock material that we set up. So I've got both tool mode and turbo mode. So if we look at this part with the tool mode, you can see as I kind of run through this, and I have the speed turned up all the way, just because this is a very large program, but if I kind of zoom in, you can actually see each part being cut out. So it goes through each one of those parts, and this will take a little while to run through, so we do have also the option of the turbo mode. So this is turbo here, and if I choose turbo mode and press play, it actually runs all the way to the end of the program, or whatever I had chosen in this little drop-down window. So it's going to go through and run to the very end of the program really quickly for me, and then I can zoom in and again see that whole part. Within turbo mode, we also have the option of an extended zoom. So if I look at this part from the top, I can actually zoom in on a specific area that I want to see, and it will actually show me a really close-up view of that and the detailed view. So this is going to up the detail of the turbo mode, which again isn't going to be set for a very great quality setting, I guess, because it is such a fast option, but we can obviously zoom into different areas and see exactly what that's going to look like when it's finished. You will notice that all of the pieces are still set inside of the parts, so all of the chips that would be normally taken out when we cut this if we run in tool mode, we do have an option right here that will actually allow us to select those chips and delete them. There is also a fast option that if we choose Control D and select the interior part, we can actually delete all of the chips at one time, so it'll actually remove all of those chips for us. But again, that's if we wanted to play through that whole tool mode setting. Within the simulation, we can actually check the options and find out the speed versus quality settings here. So if I want to maybe lower the quality a little bit, this tool mode would actually take a lot less time. So lots of different settings for our simulation as well. So once we've got all of our toolpaths set up and we've got it the way we want to machine it, then we can post-process this code, or we can go on to the next configuration. So you will notice if I drop down configurations in my CAMWorks window, you'll see the three other leftover sheets that I haven't programmed yet. So if I wanted to go to the next one, I can just double-click on that configuration. It'll let me know that it needs to switch the SOLIDWORKS configuration to that as well. And then you'll see that my parts are also in the part manager for this configuration. The stock is also set up. I would need to change my machine, so I would come back into Define Machine, choose my laser machine. Again, I've got the tool crib linked to that, and my post processor also. So there's my machine settings, and again, because I've already ran this one through Extract Machinable Features, I don't need to go back into the CAMWorks options to set up what I want it to find. So I can just choose Extract Machinable Features on this one and let that run through as well. So it's really quick process to do the next sheet. So I'm just going to choose Extract Machinable Features on this one and let it run through. So again, the more parts that you have on the sheet, the longer this will take. But again, it's much faster than having to go through and add those toolpaths in yourself. So Extract Machinable Features on these 2.5 axis contour toolpaths is a really great option, and it's really easy to use. I will also show you in the technology database kind of where I set up those strategies for the laser, and kind of how I set that up. So one option too, if you do want to set this up for a different machine, say for example even a router, if you're only doing contour toolpaths, you can actually save a new technology database and use that for laser or router toolpaths. So there's my second program. And again, at any time I can go back to the first one, just choose yes here, and then it'll go back and show me that first program that I had set up. I'm just going to do a light rebuild. It just wants to know if anything's changed, and then there's my program. So if I do go into the CAMWorks 2017 tab and choose my technology database, I'll open this up and go to my mill and then machine. So if I scroll to the right here, you'll see my fourth machine is that laser machine that I created. So again, set the laser up under the general ID. I just typed in the description of that, and again, you can be more specific on information about your laser and the brand and that kind of thing. And then specifications, your turret settings. So turret is where I actually chose that tool crib. And then I turned on tool crib priority as well as tool crib tools only. So I just wanted to use that one tool in that tool crib. So you can turn on both of those checkboxes. Spindle speed settings and setup, which we don't need because there is no indexing, fourth or fifth axis. I can also set that as my default machine if I did just use this machine all the time or quite often, then I can set that as the default machine. Under the features and operations, I also have all of my strategies set up. So if I go into, say for example, my rectangular pocket and scroll to the very bottom here, you will see my laser option. So if I look at the through laser option, I don't think I even need the blind option because I'm going to be cutting through everything. So I have my through option. It's called laser. That's my strategy name. The base attribute for this strategy is none, so I don't have a bottom radius that I want to cut. So it's either none or bottom radius, and obviously if I'm going through the part, I'm not going to be cutting a bottom radius. The stock material group, I could set this up for different materials, but I actually want to just use this for all. Then I've got the box width and the feature depth. So if you look above, you can kind of see that they've actually taken these and did different settings for different sizes. But with the laser, I can just use from 0 to 10,000 or 1,000, whatever I want to use. Same with the feature depth, so I've just set that. I've opened it up to the biggest possible. These are, again, coming from the main spindle, but again, if you had a sub spindle, you could add that in as well. So once I choose, or once I create that strategy, the operations for the matching conditions, so if everything's matching in this feature here, this is what would be created. So I chose the contour mill. If I choose the little button beside contour mill, it actually opens up all of my operation parameter settings. So I can go through here and double check everything and set everything up the way that I'd like to cut that. And then the tool selection summary, if I click on this, I'm actually using a specific tool because, again, this is just my laser tool. I only want to use this tool to cut this part out. So I can select a specific tool. In milling, the majority of the options are using an actual mathematical expression. So it's going to be the tool diameter lower expression and the tool diameter upper expression. And you can choose feature dimensions and kind of keep that within the size that you want to use for the tool. And also the tool type is at the very top, so you can choose different tools that you want. And I actually made my laser as a really small flat end mill. So that's the tool type that's chosen for that. You'll also see besides that option is the feature depth criteria. So this is basically saying this is currently using an expression, so it's taking the feature depth plus 0. So it's just saying only cut to the feature depth. Again, with the laser, if you do want to always cut a specific depth to cut through that part, you can always just use a constant. And then you've also got countersink options here if you were using the mill. So that's the rectangular pocket, and I've got quite a few different features that I've created strategies or laser strategies for. And if I go into the map mill features section, you'll notice that I've actually created one for the rectangular pocket, and then I've applied it to all the different pocket settings in this window. So if I find a circular pocket, it's actually going to treat it as a rectangular pocket and allow me to use my laser strategy that I created in the rectangular pocket feature and operations. So this kind of limits the list of what I've actually got. So this is the original feature, and this is what I want to map it to. So you'll notice that my slots, I mapped those all to the rectangular slot and then just added the laser strategy to that rectangular slot. So that's a really nice option, especially if you do want to limit this to the different strategies that you want to set up in here. Also, if I click on user-defined strategies and then I go into, for example, my rectangular pocket, you will see that I've set my laser strategy as the default. So again, this is one of the reasons why I say if you do kind of want to save this as a separate technology database for just lasers, then these are all going to be your defaults. If not, you can also easily change those defaults inside the software for any different version of machine that you're using. So I'll quickly show you that as well. So if I go into, I'll just close this here. If I go into my CAMWorks 2017 tab, there is an option called Default Feature Strategies. So if I open this up, you'll actually notice that I can actually change the default feature strategies just within this window. So it's similar to the window that I just had open in the technology database. And then I can choose whichever one that I want to change, or all of them, and then I can just take the drop down here and change it to what I actually want to change it to. So I obviously set the majority of these up to laser, and again, some of these I'm definitely not going to be cutting, so I didn't even change those. So multi-surface feature, I'm not going to be cutting that with a laser, so I'm not going to change this to a laser strategy or add a laser strategy into that feature, because I don't actually need one. So you'll see again with the holes, I'm not going to machine any of these holes, so I just left those as drill and just changed the ones that I actually want to use. So that's a really quick and easy way. Again, that's under CAMWorks 2017, and then it's called Default Feature Strategies. All right, so I'm pretty sure that that's the majority of the things that I wanted to cover today. And actually, I should show you quickly how to post-process this. So if I'm ready to post this program, I'm going to come back into my operations tree, and I'm going to either right-click on the setup and choose post-process. So if I did have multiple setups, and again, this is just the laser, so there's only going to be one, but if I did have multiple setups, I could post-process one setup at a time, or I can right-click on the toolpath and just post-process that one toolpath. Or I can use the post-process from the top here. So if I go back to my workflow, it's the very last button on the right-hand side. So once I'm ready to post-process this, save it, and I made a G-code folder on my computer, so I'm going to save that. And then it's going to go ahead and open my post-process window. So I can step through line by line and see this post being created, or I can play through the whole thing here. And this will take a little while to play through, because again, this is quite a large program. There is also this option here that is a fast option, so if I would have pressed this instead, it would have actually gone through and just created the whole program for me. It's kind of like a turbo mode for post-processing. So that's going to post the whole code, and you can see the code here. I actually have mine opening up when it's finished into Notepad, so if you do want to open it up into, say, communication software or Notepad or something to edit the code before you send it to the machine, you can easily add that in, and that's set up in the CAMWorks Options tab. So there's a File Locations tab inside the CAMWorks Options tab or window, and you can actually set all of that up inside there. And it'll actually let you know the size of that file here as well. So that is the presentation for today. So again, that's the NestingWorks. So next week, definitely if you do want to see some 3-axis machining on the mold for the drone shell, we're going to show that next week, and this is where you can sign up for it. So our website, under the events page, there's a 3D Solution Spotlight section. And thank you very much for attending. If you do have any questions, just type them in the question section of your window, and I can get back to you. And I should be here for another maybe 10 minutes. So thanks again.